Let's take a look at average rate of change. Calculate a function's average rate of change over a specified interval. You've learned a lot about intervals lately. Okay, so we're talking about average rate of change over a specified interval given the equation of the function or maybe a table of values. Approximate a function's average rate of change over a specified interval given the graph of the function. So that's interesting. The word approximate, we don't see that all the time. And finally, interpret a function's average rate of change. All of these goals are helping us find different information about the average rate of change. Are there any other math words that you could think of? Maybe when you visualize a graph that is synonymous with rate of change. Hopefully you're thinking slope. Because if the slope is steep, that is happening very quickly, right? Our x-axis is always time. If it's not so steep, this is happening more gradually over time. So let's compare some slopes. Here, we're asked to find the average rate of change from -3 to 0. That -3 to 0 is our interval, meaning between the x values of -3 and 0, what's our slope? Now, we're starting off with a basic example. This is just a straight line. So, of course, the average rate of change is the same anywhere. But we want to get in the habit and the routine of looking at intervals. So, if we look at the slope between these yellow lines, which is our interval, right, -3 to 0, we go from one point to the next, and rise of 2, run of 3. So our rate of change is 2/3. That's a nice way to get us started today. Now let's look at a different graph. Now we have a parabola, and we never really talk about slope of parabolas in this class, do we? And that's because it's more of a calculus topic if you wanted to find the actual slope. But today we are going to approximate because this is algebra 2. Okay, and we want to approximate the average rate of change from 0 to 1. So between 0 and 1, what is the approximate slope of this little curved line? Well, the way to do that is just draw a straight line and calculate that slope. This straight line here, we can all see has a slope of 1. Okay, so I'll just put a 1 in there as well. What about between 1 and 2? Here's 1, here's 2. Here's our different intervals. So between 1 and 2, we're going to once again approximate. So we're going to draw a straight line connecting one part of our graph line to the other. The slope of this, well, we go up 3, right 1, so that has an average rate of change of 3. So if we compare these slopes, what do you notice? Well, hopefully you notice, first and foremost, they're both positive and they're different, right? They're a little different. And when do they become different? Well, it seems like the further we get away from the vertex, the more different they become and the more steep the line becomes. So guys, ultimately, you've learned about slope a long time ago. Okay, so we're just thinking of slope in the terminology of average rate of change, how fast or slow something's happening, right? And we're asked to break up different segments of the line. Here we had 2 different parts. We found different slopes. Here we're asked to find the average rate of change between these two dots, and these two dots. So we're doing it the same way. Give it a try. Okay, here we have rise of 1, run of 3, 1/3. Here, rise of 1, 2, 3, 4, run of 3, 4/3. And the last, rise of 1, run of 2, 1/2. Easy peasy. Okay, what else? What else do we have in store? Just double checking. Rise over run, rise over run. Yes, yes. Okay. Average rate of change. Again, that's the topic the entire day today. And we want to find it now, though, given a table. And it's not so simple. Okay? Maybe I misspoke. It's not super complicated, but it's not the normal way you maybe originally learned how to find averages. Okay, so let's read. Find the average rate of change from 2 seconds to 5 seconds. So from here to there. And you might be used to finding average by adding up all the values. So adding up all the values right here in column Y and dividing them by however many there are. 1, 2, 3, 4, 5. That is not going to work in this situation because we're dealing with different types of graphs, different types of lines, and the average rate of change is sometimes positive, sometimes negative, okay? And if you're finding, let's say, the average amount of money you make in a month at work and you're adding up, oh, I made 120 last week, plus, 100 the week before, plus 110 the week before, plus 130 the week before that, divided by 4, that's always going to give you a positive number, right? So pay attention to how we find the average rate of change using a table. You want to identify the first value they give you as A. Boom. There it is. The second value they give you as B. Not too bad, right? Now, what if I asked you what f of A is? F of A, like this. What about f of B? Well, remember, f of X or B or A, things like this are replaceable with Y. And here we see Y. So f of A is the Y value associated with A. And f of B, right there. Okay, so great. We identified A, f of A, B, f of B. Now what? Well, there's a formula. And here it is. This is the last new thing you will need today. So once we get to be familiar with this, you are in the clear and you've got this lesson down. Okay? So a moment ago, we identified A, B, f of A, f of B. Okay, great. Look at the formula. Notice B comes before A. B comes before A. It is not alphabetical. It's actually reversed. That's one of the most common mistakes. So make sure you write this down, work with it, practice, memorize. And speaking of practice and memorize, we don't always just want to do work in our head, right? We want to write the formula. Then we want to set it up to get used to that pattern, that routine. So we're not going to subtract yet. We're just going to write out what goes in the numerator. What do you think it is? Well, f of B, we labeled that, right? Minus f of A, that was 7. Without subtracting, same thing with the denominator, B minus A. So if we work this out, what happens? We get negative 3.5 over 3. Is it 3.5? I think it's 4.5. Let's double check. 7 minus 2.5. Yes, 4.5. And that simplifies to negative 1.5, which is our average rate of change. So see what I mean? We got a negative number there. So we need to use this procedure time and time again. Different function. What's different? This time we had a table. We weren't given a function, just a table. This time we're given the function, no table. And we're asked to find the average rate of change from 23 to 43 using this function. Same general idea. Of course, it's not a table, so process is a little different. What's A? Well, it's the first value they give us. What's B? Second value they give us. Now is a great time to test yourself and see if you can solve this correctly. B and A are already found, so our denominator is set up. That was pretty quick. F of B and F of A. Well, we have a function, don't we? Can we use it to help us find F of A and F of B? Absolutely. If we know A is 23, plug it into your function. Fortunately, we get a perfect square. F of A is 4. Same thing with F of B. Another perfect square. F of B is 6. Plug those values into your numerator. Subtract and simplify. Average rate of change is 1/10. And it's time for an independent practice problem. Another good opportunity, of course, for you to practice. You have a function, and you're being asked again, what's the average rate of change of f of x from 4 to 2? And this is going to be our last problem for the day. Let's see how you did. A is 4. B is 2. F of A is the same as F of 4. PEMDAS, square, multiply, 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 add, subtract. Same thing here, F of B, B is 2. So plug in 2 to find F of B. Once again, using order of operations. Finally, we get here, we add, we'll actually multiply, and then add, and then divide. Negative 17. Not too bad, right? Practice, that's how you get better. That's all for now.